Hi friends, let's say you're traveling to your friend's house or your cousin's place. If I ask you, what's the distance traveled? How do you practically measure it? What about displacement, speed, velocity? In this video, I'll be driving around in the car and showing you exactly how to measure these things. But before we jump into the exciting practical stuff, be sure to watch the part 1 video on the basic concepts. Then you'll find it much easier to relate the theory and its practical application. And as usual, we'll finish off with our top 3 questions on this topic. So are you ready? Let's go to the car and take a look. Okay, we are back in the car now. Suppose you're going to travel to your cousin's house. What's a practical way to measure the distance you're going to travel? Of course, you can't use a rope or a measuring tape now. In all the vehicles, whether it's a car, bus or bike, you'll have a panel like this. There is an instrument here called an odometer. Do you know where it is located? That's correct. This is the odometer. It measures the distance traveled by the vehicle. Can you see the unit used? Kilometers. Before you start, you can note the odometer reading. As you can see, it's 10,180 kilometers. As you're traveling, the odometer will keep on ticking. Now let's say when you reach your destination, the odometer reading is 10,185 kilometers. So what's the distance you've traveled? That's right. You just have to subtract the two readings. So the distance here is 5 kilometers. We know how to measure distance. But what's a practical way to calculate the displacement from your house to your cousin's place? Remember, displacement is the shortest path from the initial to the final position. And the shortest path is a straight line. So it's almost as if you're flying to your cousin's house. Just like that bird there. So it's not possible to use any of the instruments here. We need to use some geography. We need a map. Here's our map. First locate your house and your cousin's house on the map. If you travel by road like this to your cousin's house, the length of the path traveled is called distance. As we discussed, we can calculate it by using the odometer in the car. Now let's look at displacement. Displacement is the shortest path from your house to your cousin's house. And the shortest path is a straight line. As if you're flying to your cousin's house like a bird. So for displacement, let's draw a straight line from your house to your cousin's place. Now measure the length of the line using a ruler. The length here is 3 centimeters. Let's see what is the scale of the map. Here it says 1 centimeter equals 1 kilometer. So 3 centimeters is 3 kilometers. So the displacement from your house to your cousin's house is 3 kilometers. Displacement is a vector quantity, so we can give it a direction. Here's the north of the map. So what is our displacement? It's going to be 3 kilometers in the northeast direction. While traveling, how do you calculate the speed of your car? You may have already heard of this. There's an instrument called speedometer in the panel here. In my car panel, there are two things that look like a speedometer. But it's not this one. This one is a tachometer. It measures the rotation speed of the shaft in the car. This one is the speedometer. It measures the speed of the car. As you can see, the unit is kilometers per hour. Now question is, does the speedometer measure the average speed? What do you think? I'm going to start the car and drive, and you carefully observe the reading in the speedometer. Can you see the initial speed is 0? And it's increasing as the speed of my car is increasing. So it's not measuring the average speed. it's measuring the speed at this instant. It's called instantaneous speed. For example, the speed of my car right now is 30 kilometers per hour. How does a speedometer work? It calculates the distance traveled in a very short time interval, say 1 second or 0.1 second. And so instantaneous speed is the distance traveled in this short time interval divided by the time interval. While traveling, the instantaneous speed of the car keeps on changing. So it's more useful to look at the average speed. What's the formula of average speed? It's total distance divided by total time. Total distance can be calculated using the odometer. So it's the final odometer reading minus the initial odometer reading. And total time is easy to find. You just check your watch when you started and the time when you reached. And if you subtract the two, you get the total time. For example, let's say we traveled 5 kilometers in 20 minutes. 20 minutes is 1/3 of an hour. So if you divide the two, the average speed is 15 kilometers per hour. How do you calculate the velocity of the car? Remember, velocity is speed with direction. The velocity at any instant is the speed at that instant and the direction. This is known as instantaneous velocity. For example, the speed of my car right now is 20 kilometers an hour. And let's say the direction is north. So the instantaneous velocity is 20 kilometers north. How do you calculate the average velocity of the car? Average speed is total distance divided by total time. Similarly, average velocity is total displacement by total time. For example, if the total displacement is 3 kilometers and let's say the time is 20 minutes, which is 1/3 of an hour. So the average velocity is going to be, if you divide the two, 9 kilometers per hour. Now let's talk about uniform and non-uniform motion. A body is said to be in uniform motion if it's traveling equal distance in equal interval of time and in a straight line. Now what does this mean? Let's take a time interval of 1 second. So if my car is traveling 5 meters every 1 second and in a straight line, then it's in uniform motion because the speed is constant and the direction is the same. Now speed with direction is velocity. So an easy way to remember uniform motion is that it's constant velocity. Non-uniform motion is the opposite of uniform motion. If a body is traveling unequal distances in equal intervals of time, then it's in non-uniform motion. Not unequal distances in unequal intervals of time. Then it's going to be really confusing. So the time interval needs to be kept same. For example, let's say my car is traveling 2 meters in the first second, 3 meters in the second second, and let's say 1 meter in the third second. So every second the distance traveled is unequal. So the car is in non-uniform motion. So in non-uniform motion, the speed is not constant. When you're traveling, are you usually in uniform motion or non-uniform motion? That's right, it's non-uniform motion because the speed of the car keeps changing. When the car is stopped, the speed is 0. On an empty road, the speed increases. And when you're in busy traffic, the speed decreases. So clearly, it's a case of non-uniform motion. One practical example of uniform motion is the cruise control feature in cars. My car doesn't have that feature, but in the cars that have it, you can use the cruise control feature to set the speed of your car at a particular value. So if you're on a highway, your car will be moving at that set speed. So this is a case of uniform motion. But mostly while you're traveling, you're usually in non-uniform motion. Now we are done with the concepts. So are you ready to take a look at the top 3 questions on this topic? Question 1. What does the speedometer of a vehicle measure? Question 2. A car is taking a turn at a uniform speed, like this. Does the car have uniform velocity? Question 3. A car travels at a speed of 20 km per hour for half the distance and at 30 km per hour in the other half. Find the average speed of the car. So here are the 3 questions. Try solving these questions and do write your answers and doubts